Better Buildings for Humans is powered by Advanced Glazings, makers of the Solera line of products. Solera is the leading glass glazing made specifically for architectural daylighting and with extreme insulation performance. Learn more at advancedglazings.com. Hello, and welcome to this week's episode of Better Buildings for Humans. This is the podcast where we explore the impact that the built environment has on our health, our wellness, our productivity, our general joy of being alive. And of course, we always talk about sustainable design as well. I've got a special guest this week. I've got Garrett Herbst from Little Diversified Architectural Consultants, and we'll just call them Little, as Garrett had advised me. And we'll go from there. Garrett, welcome to the show. It's wonderful to have you here.
Thank you for having me. I'm very excited to be here.
It's an absolute honor. Let's get things moving by having our listeners learn a little bit about you. It's always great to learn about the guests first. Tell us why you chose architecture as a career, and maybe the path that led you to working for Little, and how you became interested in using computation to elevate design.
Yeah, absolutely. So the start really began in high school. And, ironically, it started with computation. So my high school, I was very fortunate to be in a high school that offered a architectural drafting course along with engineering and a couple others. And I was able to use Autodesk Revit, which is our primary software that we use in architecture, really early on. And I found that I was constantly staying late, staying after school, coming in at lunches to work on, my dream house. I put in a football stadium in the basement and just like constantly was working on it. Loved the modeling side, loved the ability to create within the digital environment, which led me to realize that architecture is what I wanted to do. I wanted to do that for my career. And so that led me to, starting to look at colleges, realized I needed an art portfolio. So I took all the art courses I could take my junior and senior year, realized I fell back in love with art, and ended up at the University at Buffalo, where I did my undergrad, which then led to me coming to UNC Charlotte for my master's program. And really, so again, like computation has always kind of been the real passion of mine and what led me to architecture. And it always has been in the background, something that I have wanted to pursue and has always interested me. And at University of Buffalo, I had taken some courses. They really focus on more traditional design processes there. And there were some advanced computation classes. I'll admit that I actually struggled the first couple classes that I took for parametric design modeling. So node-based scripting like Grasshopper, I was not good, but I kept at it. And when I came to UNC Charlotte, I really kind of buckled down and learned as much as I could, watched as many YouTube videos as I could, and really became proficient and ended up more times than not kind of acting as the TA in my computational classes, helping out other students with how to use the software, how to effectively apply it to their projects. And that actually led me to doing my thesis on creating a Dynamo script that effectively, the thesis was all around fog harvesting materials and how much water you could collect from a building facade, both rainwater and particulate, condensation or fog. And I wrote a script that essentially took a building mass, analyzed it for how much water potential it could yield, and then could also optimize the form, the rotation, and then also apply the facade systems in the most optimal locations on the facade. And that was all done through Dynamo, and I ended up receiving the best thesis project for my class. And all that kind of led to me being hired at Little. So they actually were doing a competition that focused it on fog harvesting. So me and Tomas Eliasson, one of the design principals here, really connected on that and found my way to Little. And then at Little, I've been actively, researching and trying to integrate as many advanced computational techniques as possible, which has led to me helping co-found and lead the Emerging Tech Collab, which is our group here that is kind of just looking at all things emerging technologies and advanced computation. So that includes AI, that includes digital fabrication, any kind of automation or scripting software. And yeah, and it's been an incredible ride, but it all seems to have kind of been leading up to where I am today and all building on itself.
That's a fascinating journey. And the part that I find particularly fascinating is that you normally don't find, that desire to dive deep on the digital side of things in combination with a love of art and a
Yeah.
passion for art. So it's a really interesting and really nice combination. So I compliment you for that. Before we move on, and I want to talk more about computational design, but I have to talk about the fog collection. Where did
Yeah.
that go? Can you tell me a little bit about the methodology and materials you were using for that and where that project has ended up?
Yeah, so that project was published. I can't remember the exact conference, but it was in Barcelona as a paper. And unfortunately, it hasn't really gone too far, just because with the way building methodologies are today, it unfortunately it's like a lot of thesis projects where it kind of ends up just being an idea. But it still has kind of led to a focus and tied in with the regenerative design pursuits and direction that Little is taking. That's our HEWS, which is HEWS, W standing for water and water collection and preservation. The material itself, so it all started with a project that I did that focused on hydrophobic materials. So materials and surfaces that, reject water and kind of push water away. Very predominantly, people use hydrophobic coatings on their shoes to protect them. That led me, it originally started with ETFE, which is the plastic pillows, very famous Alliance Arena, as well as the Shed in New York. But then that led to finding actually a lot of communities in South America, I believe. And it's been a while, so I might be off a little bit, but people in more mountainous environments, they don't have access to a ton of water sources, but they have a lot of access to fog because they're at such high elevations that clouds literally will run into the sides of the mountains. And so they've actually integrated these kind of net like structures that the clouds condensate on. And then once it gets to a certain mass, the water droplets fall into a collection system. And MIT actually had taken that idea and developed a mesh that was specifically designed to be as hydrophobic as possible and to target particulate water particles that could be as efficient as possible. So I was using some of the research and the metrics that the MIT research had done to integrate into the script, and then had used some additional metrics, weather data and some research that a previous student had done on rainwater vertical harvesting to develop the script.
Do you want to bring lots of healthy, beautiful natural light in your building and still meet energy codes? Try Solera from Advanced Glazings. Learn more at advancedglazings.com. Brilliant. Absolutely brilliant. All right, let's talk computational design.
Yeah.
First and foremost, could you please define it for our listeners and then tell us how it's useful in design?
Yeah, so computational design is a really interesting term because honestly, 90 to 98% of what we do in a typical day is on the computer. And so a lot of people typically will tie computational design with more advanced computational techniques like parametric modeling or scripting. But really, it's how we use and leverage computation to make us better architects, make us more efficient, make us more accurate, and be more detailed. And so that's really how we look at computational design. And that's how we try and integrate computational design into our process here at Little. Really just finding all the new methods, the new avenues, the new ways that we can leverage the power of a computer to make us better designers.
So, if I was a client of yours, why would I be happy that you have this high level of familiarity with the techniques of computational design?
Yeah. So, I mean, there's a lot of reasons why a client would be happy to know that we're using and leveraging these computational techniques. One is that they are higher quality. It leads to better accuracy, better documentation, more detailed documentation. It allows us to iterate faster, right? So before, right, when you would have to hand render a elevation to show a client what the building would look like, that would take a really long time. Now I can do 3 to 5 options of an entire building design and render it in 3D with the materials that we'll have in the environment that it's going to be in, and really give the client a much better sense of what they're going to get, and to allow them to be able to react to it and give much more focused feedback than they would before. And it really just leads to more innovative designs and a more efficient process. We can do projects quicker. We can do them much more detailed, like I said. And it really just results in better projects moving forward, as well as higher coordination with the contractors, right? The people who are building the actual architecture. We're getting to a point now where we're actually sharing our BIM models, our 3D models with the contractors, so that they can actually see in 3 dimensions what they're trying to build and what our intent was. And it leads to much better coordination, much better QA/QC process, and a lot more streamlined construction process in the field.
That's a great step forward. I love that. What about the perspective of the people occupying the building? How does it become a better building for them by employing these methodologies, these techniques, these technologies?
Yeah, absolutely. So there's a lot of different categories, I guess, for the building occupant. One is that we can visualize and actually design more of the spaces that people will be occupying and know what it's going to look like, know what it's going to feel like, know what the light levels are going to be, know what the heating and cooling potential is going to be for the solar orientation, right? We can do high quality analysis, environmental analysis on the building massing as we're designing it. So we actually have a script here that can take a building mass and take the location that it is geographically and optimize its orientation based on the position of the sun, how much glazing it has, and also the surrounding context. So if it's in an urban environment and you have a couple tall buildings on one side but not the other, it can actually orient the building correctly and analyze not only what the solar radiation is going to be on the building mass itself, but also how those contextual buildings are going to affect that radiation. Even trees, right? So trees predominantly aren't, when people think of shading devices, they think of louvers, they think of big overhangs, canopies, but trees are an incredibly effective shading device for low-rise buildings, and we can actually integrate tree massing around the building to show how much that actually will reduce the radiation, the exposure of the building to the sun. And then also, in terms of post occupancy, we can leverage computation to make sure that the building is actually working in the way that we designed it, right? And identify any areas that aren't working efficiently and can address it in real time.
Oh, I love that. I really love that. I have to go IT on you for just a minute. Do you have a bunch of really high powered machines on your desks, or have you got your own little sort of data center within your offices? How are you managing all of that processing capability,
Yeah, so
capacity?
we have actually been using a cloud-based system since actually before the pandemic, since I started in 2017, and they were using a cloud-based system before I started. But it is a really powerful way to leverage the power needed for this type of computation, because you can effectively plug in as much power as you need and build a machine virtually, using obviously the resources that are in the data center, I believe in DC. So we're able to elevate certain machines depending on the need that they have. We also have some internal hardware here that we use. So our visualization team has a physical render farm that they use to generate all of their different visualizations, as well as we're actually planning on building our own server specifically designed to run AI models, both text-based large language models, as well as image generation AI models.
Very cool. Now, you are an adjunct professor at UNC Charlotte, right?
Correct.
And so how do you approach teaching students such, advanced computational techniques in a way that they're able to digest all of that?
Yeah, it is tricky. And I will say my experience in grad school, kind of being the TA, really showed me how you need to really start at a basic foundational level and then grow from there, right? So sometimes professors will jump right in. They'll kind of assume that students know the basic foundational techniques and are just going to learn the basics on their own. And for a lot of people, that quick advancement scares them and kind of shuts them down in terms of learning the software. So I really try and start the course at a much lower, very foundational level, very basic, and then quickly but incrementally build up their skills to the more advanced techniques. I've taught both the computational methods and practice courses. The methods focuses on Rhino and Grasshopper. The practice focuses on Revit and Dynamo. Both of those started in just the 3D model, really just understanding the basic tools and the basic functions of the software, and then gradually introducing them to more and more of the software itself, leading to then moving into the scripting side of the platforms, and then again walking them through very slowly how you can build, what is the actual kind of mindset you need to have when you're doing these types of scripting tools and scripting workflows. And what I actually have found, which some professors would argue against, but I found was really effective, was pre-recording the tutorials and uploading them beforehand, so that I'd start the class and walk through kind of what they would be doing, but then they can then go off on their own and walk through the tutorial on their own pace at their own time. Because what I found was in every class you have people who are kind of beginners, there's intermediates, and there's students who are more advanced, right? So the advanced students kind of blow through the tutorial and they get kind of bored. And then the beginners, they might have a ton of questions. And what I found was a lot of people were asking questions. And then I think they started to get a little embarrassed about asking so many questions or having me repeat something. And so they would just stop. And then, of course, they get lost. So the video tutorials allow people to move at their own pace, to pause the video, to rewind the video whenever they need. And then I'm there as a resource in case I need to walk through anything more in detail or explain something further.
Very cool. Garrett, I want to go off script for just a short journey. All of that processing, especially when you bring in AI, it's pretty energy intensive. Has anybody ever talked about, the ROI, I guess the energy ROI or the energy payback relative to the energy that's consumed to do the computation, and then the payback being designing much more energy efficient buildings? Is that a road that you've gone down, or that are you aware of anybody going down that road?
It's not a road that I have gone down personally, but we have designed a lot of data centers, and obviously they are very energy intensive.
Yes.
And so we typically will try and find as many different avenues of making the building as efficient as possible. And that really starts with facades and making the facade and the building as airtight as possible so that the energy required to cool it is as minimal as possible. I know there is at least one example, if not more, of companies actually submerging their data centers underwater to make it more energy efficient. And I just saw an article, and unfortunately I did not read into it too much. I just saw the headline, but that some companies were starting to utilize certain AI models to optimize the energy use in data centers that were powering AI. So AI was literally helping make the buildings and the energy required more efficient for themselves.
Very cool. All right. I want to read a quote. It's from your bio page at littleonline.com. Here's what it says. Equally passionate about regenerative design, Garrett is an avid researcher at UNC Charlotte, where he's at the forefront of developing next generation facades. That the conversation we were just having. His research notably focuses on the integration of microalgae and photovoltaics, paving the way for a new era of sustainable and energy efficient architectural solution. Let's talk about this next generation of facades.
Yeah.
What does it mean to you? And let's focus on the microalgae. That's the part that's like very interesting. How does that all fit together?
Yeah, so I had the opportunity to work with Dr. Kyung-hee Kim, who is a professor at UNC Charlotte. She worked for Front Inc., which is one of the leading facade consultants in the world. They work on pretty much every high, quote unquote, starchitect building. And she has a passion for facades, and so do I. And so I worked with her a little bit as a research assistant when I was in grad school. And then coming out of grad school, she asked me to help build some prototypes for a research project that focused on the microalgae. And that led to 2 rounds of grants from the National Science Foundation. So I think 6 years I've been working for her on and off. And the research is really interesting. So the grant specifically is designed to take research and move it into a marketable product, a commercially viable product. And so that was really what the research was focused on. So there's a lot of research, and there's a couple examples of algae being integrated into building facades. The most famous one being the Bick House that Arup designed, I believe, in Germany. But if you look at it, it looks, no offense to any engineers, it looks like it was designed by engineers. It's a big green block, basically. And so she was really focused on how do we make these as aesthetically pleasing as well as being as efficient and environmentally, a carbon offset as possible. And so that was one of the big targets that we had for the research, was not only integrating the microalgae technology, but also doing it in an aesthetic way that would be attractive for clients and would make clients want to integrate them into their buildings. So I say all that, and I realize that I hadn't actually talked about the microalgae itself. So the microalgae is a really interesting technology. So algae is one of the largest carbon offsets in the world. It offsets and eats carbon dioxide and produces a ton of oxygen, more so than pretty much every plant species in the world. Interestingly enough, the oceans actually produce more oxygen than the landmass on Earth because of algae species. So the main principle of the microalgae, integrating them into facades, is to offset the carbon footprint of the building. And by doing so inside the building, you can actually take the carbon dioxide that the occupants are offsetting and run it through the algae system and have it essentially scrub the air and then release the more oxygen rich air back into the interior environment, making the interior air quality much better. And then algae has a ton of subspecies, which also have a ton of different byproducts. So the most common one is food supplements. So they are really high in minerals and vitamins. And they don't have any taste. So you can integrate them into different foods. Some have pharmaceutical applications. There's one species that we're growing that is actually worth more by weight than gold. So definitely a viable financial result for that species. And then also there's some that secrete an oil that can be harvested for biofuel. So you can actually harvest the algae and then convert it into biofuel to heat the building. There's soil added. There's some that unfortunately we're able to get to grow when we're doing the tests, but is bioluminescent too. So I'm sure you've seen the bioluminescent algae around the world. There are some that you could integrate that could actually make the building glow.
Oh, that is really cool. How do you actually extract that biomass, Garrett?
So they're essentially the facade system, the microalgae system is essentially just a tank. It's basically an aquarium that we design into funky different geometric shapes. But it is mainly water with the algae integrated and then some food supplements as well. And so the algae will go from a really low density to full maturity pretty quickly, 2 to 4 weeks. And then you essentially will empty the system and then take the algae, you can filter it and get the biomass, and then take it to whatever type of post harvesting production facility you need to harvest the byproducts.
So there's some external infrastructure that we'd have to put in place for that to have broad adoption. Okay.
Correct.
Okay. Yeah, that's not a bad thing. That is a very good thing. I like that. Let's talk about mass timber. You're doing
Yeah.
projects with mass timber. I was just involved with a 13,000 square foot facade with our Solera wall, our frameless glass system, gorgeous, functional, the whole 9 yards. And it was amazing how well it integrated with the mass timber. Anyway, question that I hear regularly: how does cutting down trees result in a lower carbon footprint?
Yeah, so that is a great question, and I understand people's initial reaction to it. But what people need to understand is that trees are renewable, right? You can always grow more trees. And I think people, they automatically assume that, oh, it's mass timber, you're building these big structures. Mass timber is not, we're not cutting down big trees and creating these really large timbers. They are your typical 2x6s, 2x8s that are just glued together. And so no one seems to have a problem with the people using 2x4s, 2x6s to do all the different residential, but they get a little scared when they hear these mass timber. So I understand people's reaction to cutting down trees. It seems counterintuitive to being more environmentally friendly. But when you cut down a tree, you're actually carbon positive, because in the life of that tree, it is constantly absorbing carbon dioxide and releasing oxygen. And so it has absorbed a ton of carbon from the environment throughout its entire lifespan. And so when you cut down that tree, you actually are carbon positive. Whereas if you were using any other traditional building materials such as concrete or steel, you're automatically in the negative. And the production of those materials is very harmful to the environment. It releases a ton of carbon in the air. And so the idea is that you can be more carbon positive in the early stages of a building. And then also throughout the production process, it is a much more efficient and much more environmentally friendly process. So the fabrication is very limited in terms of its environmental emissions. It's a lighter material, so you can transport it much easier. And then it's also modular. So most of the mass timber elements are prefabricated. And so when it gets on site, it goes up much quicker than your traditional methods. And so quicker construction means less time that equipment needs to be running, less days that employees, construction workers have to drive to the site and drive back. And there's a lot of different resources out there. And again, it's a renewable resource, right? So there, pretty much every forestry and wood production facility that I've ever been to, they have people on staff that is constantly maintaining the forest that they cultivate from, because if they run out of wood, then they're out of business. So they are making sure that they're not going through and just deforesting large swaths of land, and that they're doing it in a renewable way. And again, compared to your traditional methods, steel and concrete, it is a much more environmentally friendly building material. It also leads to better mental states for people. So there's studies done that reduce blood pressure, reduce stress, and it's just a warm environment. It feels much better. It's not as cold, and you can leave a lot more exposed. So you're reducing the amount of interior finishes that you need. We've done some studies, and on average, compared to a steel or concrete building, you're looking at, over the lifespan of the building, a 60 to 80% reduction in the carbon footprint of that building.
Manage the connection between building occupants and the outside world using Solera translucent glass. Learn more at advancedglazings.com.
Interesting. And you forgot one thing. It's gorgeous.
It is gorgeous.
It's stunningly beautiful on top of all those other advantages. All right. We have not yet talked about regenerative design. Can you please define it and help us understand it better with a few examples?
Yeah. So regenerative design, at least here at Little and throughout the discipline, is really trying to focus on not just the operational efficiency of a building. I think that's what most people think about when they think about sustainability, is how much energy am I using to power the building, right? But when you think about regenerative design, you start to think about all the different aspects that a design has an effect on. So at Little, I mentioned earlier, we have the HEWS. So HEWS stands for health, energy, water, and social equity. So health, right, making sure that our buildings are designed to improve the health of our occupants. So not only making sure that indoor air quality is good and that we're comfortable, but also integrating as many design elements that promote physical activity, promote healthy eating, promote water intakes. Energy, of course, making sure that we're reducing our energy need and reducing that operational costs and improving the efficiency of the building, but also looking at different passive ways that we can design the buildings to be more energy efficient. Like I mentioned, the orientation, passive solar, shading strategies, water, of course, looking at all the different ways that we can recycle the water that falls on a building. There's so much rainfall. I actually installed a rainwater collection system at my house, and it's incredible. I think it's like a 400-gallon tank, and it is filled in 2-3 rainstorms. I mean, you can collect a ton of water from a building, and most of that just goes into the stormwater system and goes back into our wastewater. And so how can we effectively use that water to do simple things like use in our toilets and reflush system, irrigating, right? So many people are now integrating different outdoor amenity spaces, and all those plants need to be watered. And so you can use the water collected to just irrigate your plants. And then social equity, which is a big one, right? So not only how can our buildings improve the life of the occupants that are going to be in the building day to day, but how does it affect the community, and how can the building actually give back to the community? So whether that be different community programs, allocating outdoor public space back to the neighborhood, or integrating certain amenities like community gardens or bee colonies or something like that can really elevate not just the company or the occupants of the building, but also the people and the community that is around it.
Very cool. All right. Let's talk style for a little bit. I'm trying to make sure that I don't spend the entire time on science and the engineering science aspects of things. I want to talk a little bit about style. Do you have a particular style or movement that you like to work in, Garrett, when you're designing? Or are you just drawing from different elements depending on the building itself?
Yeah. So I'll start with my favorite style, and then I'll talk a little bit about how we design, because they're a little juxtaposed. So my favorite style, my favorite architect is Morphosis, Tom Main. They do incredible designs. I'm sure most people, you look at it, you either love it or you hate it. It's kind of one of those styles, but they're always looking at different ways of doing facades, creating space, refining space. And as much as I can, I at least try and integrate those proportions into our buildings. The materials and the structure that they use is a little bit too out of our typical price range. But then I also look at Bjarke Ingels and Big, and their designs are relatively simple, but they're innovative, right? They basically come up with a really simple idea and execute it in a way that really hasn't been done before. So one of my favorite examples of his is the Court Tower in New York City. It's right on the East River, I believe. And it's an apartment complex, and it's in the orientation of a traditional European housing complex where it has a big courtyard in the middle, but then it takes one corner and just lifts it up so that it relates to and is at the density needed for its environment, but does so in a way that allows all of the occupants to have a really nice view of the river and is a really unique form. And it really stands out on the skyline. And so those kind of simple ideas and diagramming those ideas and explaining those ideas and really simple concepts that the client can digest is definitely something that I try and integrate as much as possible, because really, clients can buy in to a really kind of forward-thinking design, but you need to be able to convey that message and have them buy in and really resonate with the idea before they'll do it. But if they do buy in, it's incredible how quickly they'll jump in, and financially they'll make it work, and they'll kind of take other things out and make sure that we have enough money allocated for that specific design idea. And so, and the way that we design at Little, right? So we start with, we don't necessarily have a style. We're a commercial design firm, and we understand that clients have a specific style, they have a specific brand, they have a specific aesthetic. And so we typically start every design process with a visioning session, and we walk through their desires, they walk through their wants and the things that they want to stay away from. And then we use a ton of imagery to really gain a sense of what their aesthetic desire is. And so they'll walk through, they'll put, we have green and red stickers. We'll put them on the images that they like, the images that they don't like. And then we start to take all of those different ideas, the different aesthetics, and start to blur them into our own design creation, so that we're not starting from scratch and we're not going to be designing something that we know the client isn't going to like.
I like that a lot. Yeah, great methodology for, I'll say, filtering the aesthetics. It works. Yeah, brilliant. All right. So we've reached the point in the show where I asked my $1 million question, Garrett, and I asked the same question of every guest, and I asked them to answer it from whatever perspective they'd like. What makes a great building?
What makes a great building? So I think, God, there's a couple different ways to answer that. But what I think what makes a great building is, does the occupant enjoy going into it, right? Coming to it, being the occupant, whether that be a residence and they love their home and they love the space that they reside in, or it's someone who goes to work and they love their office and they love the building and they want to go there. And there's a ton of different reasons why someone would, right? So whether that be the amenities that are there, the unique spaces, like for instance, our office, I love coming to our office. We moved here in 2020 and it has so many different aspects to it that just makes working here enjoyable, whether that be the big monumental stairs that cuts through all the floors and you can go up and down it and it's beautiful, to the model shop, which I spend a lot of time in, to the really unique kind of individual spaces like the one I'm in right now that has these incredible views, that's very private. And there's a ton of different dynamic environments throughout the space where you can really find whatever you need any time of the day. And so again, like that's really what makes a building great. And in my opinion, what all buildings should be doing is serving the occupant's needs to the best of its ability.
Great answer. I love that. Okay, before we go, is there any news that you'd like to share, any big announcements or anything you'd like to promote, Garrett?
So the biggest announcement, so keep a lookout for new announcements from Little revolving around AI and advanced computation. So the Emerging Tech Collab, we started just a year ago now, but we have grown really quickly and we're making a lot of incredible advancements, both for the firm and for the discipline. And we will be putting out different news articles, different posts. We'll be going to a couple conferences coming up. So keep an eye out for all things coming out of Little revolving around the Emerging Tech Collab. So we have grown really fast and have implemented a ton of different technologies and tools within the firm. And we are actually starting to focus more on internal tool development. So hopefully we'll be coming out with a lot of announcements or articles talking about the ways that we're integrating AI, that we're integrating automation and scripting tools within our process, and hopefully coming out soon with some tools of our own. That might be a little bit on the horizon, but that's our goals for the next year or two. So we're in a really exciting time. I think Little specifically is leveraging AI really effectively and in ways that a lot of firms just aren't doing yet or haven't caught up yet. So really excited to be a part of it, and I can't wait to see what comes next.
Well, when the collab reaches the right point of maturity, we'll get you back on the show again to talk about it.
Absolutely. Can't wait.
Fantastic. Garrett, thank you so much for your time. It's been a real blast talking to you.
Thank you.
All right. Take care.
Have a great day.
We hope you enjoyed this episode of Better Buildings for Humans. For more information on the world's best light diffusing and highly insulating glass glazing, please visit advancedglazings.com.